Hey everybody, this is Larry. This is us doing week 5 of the premium challenge. So hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this one. So we haven't done this one yet, doesn't seem like, right? Yeah, so I'm excited. Though I still want to take a nap, so we'll see how that goes. But let's get to it. Okay, I clicked on description and now this is stuck. Is my computer stuck? Or just my Firefox? Something stuck. Alright, let's click on refresh. That didn't work. Okay, maybe my Firefox is stuck. Sorry friends, technical difficulty. Maybe I should have read the problem first so I could at least talk about it. What is going on? Huh. Alright, I refresh. Maybe that'll be fine. It was using 4 gigs of memory. Why is Leetcode using 4 gigs of memory? I don't know. Alright, let's take a look at today's problem. Sorry for the technical difficulties. We have 2464 minimum subarray in a random split. We haven't done this problem before, so it's very exciting. Welcome to a new video. You from the future. Let's read the problem. You're given an integer array num, split in an integer array nums and subarrays. It's valid if the GCD of the first and the last element of each subarray is greater than 1, and each element of nums belong to exactly one subarray. Return the minimum number of subarrays in a random subarray splitting of nums. If a random subarray splitting is not possible, return -1. Note that GCD is subarray. Okay, so let's take a look at some examples to make sure we understood it. In here we could split 2 and 3 and 2 and 6. Oh wait, is it greater than 1 or okay? Oh, oops, my fault. I thought it was going to be 1. Okay, so then you could do 2 and. Does it have to be at least 2 elements? Because I was curious whether why we can't do like 2 and 4 and then 3, but maybe you can. I just want to see. Subarray can. Okay. It's a little bit awkward. But I would say taking a sneak peek at the constraint, and maybe I should have taken a look at that first. N is equal to 1000, and that is pretty critical because that means that n squared is good, and if n squared is good, then this is just a very simple dynamic programming problem minimization, or maybe even shortest path in a DAG really. And the shortest path in a DAG, you can do it with just the shortest path solution, right? So you could do this already with DP, you can do this with shortest path, and there's a variation of this in which you have to be able to do it much quicker, but I don't think that is the case for this particular problem. So let's just do it. I think normally I would write this in DP because it's very straightforward, but I am going to play around a little bit with shortest path because I don't think I normally do this with shortest path, so maybe that'll just mix things up a little bit. And the idea here is, just to be clear, let me actually draw it out real quick. I do this diagram kind of often, but I also always like people to kind of be like, what I want to say is, you know, you have to be very specific about your visualization about this sometimes. And I think sometimes this is why people get off by ones on DP and stuff like that when they're not clear. And what I mean by that is that, let's say you have these numbers, and I'm just, well, that's not a number, but just like random numbers, right? And it's very often that you maybe like think about DP on the index, and I write things in that way as well, and shortest path on the index or whatever. But actually, what you should, you know, just have a visualization about is that we are there are like these spaces in between the and before and after the actual numbers, and then in that case you want to draw edges that goes like, you know, whatever, and in this case this means that 2 and 2 has just a GCD of greater than 1. I guess 5 and 4 doesn't actually make sense, but 5 and 5 does, because 5 and 5 has a GCD of greater than 1. And then now once you draw all these edges, and in this particular problem you can draw all those edges, not always true in these sorts of problem, but in this particular problem, because the number of edges is n square, and n square is just 1,000 square, which is 1,000,000, which you can draw all the edges on, right? And then as a result, now you have all these edges. I'm going to draw random edges, so that, even though it doesn't make sense, but then now you're just trying to get the shortest path from here to here, and that is it. And of course, another thing to notice is that all these edges, you can draw them in a way that is a dag, right? Meaning that they only go in one direction. And when you draw them as in a dag or as a dag and going in one direction, well, this allows you to do dynamic programming. And what that practically means, I mean, you know, implementation wise, I don't think it's like you should be able to get to a point where you could do either or both, either and both really. But so one is practice, the one that you're less familiar with, and two is that what was I going to say? Something about implementation. Oh yeah, but in an actual contest or in a interview situation, choose the approach that makes more sense for you, right? Like if you're really strong at BFS, shortest path, then do it that way. Don't try to, you know, an interview is not time to show off unless you're really confident about it, right? So yeah, so those are kind of the things that I want to talk about. So now from that, we can solve the problem, right? So we would say, you know, this is going to be a BFS shortest path, right? Yeah. So then right, just 0, right? And then someone just fell. And this instance is equal to, let's say infinity times n, right? To the n or n plus 1. No, it's n. Oh, no, it's n plus 1, but the last index is n, right? And we define infinity. Right? And then now we can just do, you know, this is going to be mostly boilerplate in a way, right? So current is equal to q.pop left, right? And then now we just look at, you know, there is an edge from node I to node j if num sub I and num sub j minus 1 is it j or j minus 1? GCD has a GCD greater than 1, right? I mean, so when I get a little bit confused, this is where I pull back up, you know, this is why I put it this way, and I'm getting confused right now, honestly, right? So for example, this is 0, right? This is 0 index, this is 1, so there's an edge between 0 and 1 if index of 0 is good, right? In this case, 0 and 0 being the two endpoints. So if I is equal to 0 and j is equal to 1, then we check 0 and j minus 1. So that should be good. And they have, well, I don't know why this is 0. Oh, this is index 0, but you don't check 0. You check the index 0, just check that the GCD is greater than 1. So yeah, so I think this is correct. And current is the I per se. So then maybe we could write for j in range of n plus 1. Because now, if this is n, if j is n, then we could check n minus 1. Or wait. Yeah, no, if it's n, then we check n minus 1 on the nums, right? So yeah, so then now if GCD of current, well not current, but nums of current, and nums of j minus 1 is greater than 1, then now there's an edge. And then we do the whole BFS thing, right? So then now if this is the case, well, there's an edge. I mean, we could kind of combine these if statements, and what I mean is distances of j is greater than distances of I plus 1, right? This is regular BFS stuff. And in that case, we update this to 2, and then we q.append j, right? And that's it. And then now we just return distances of n minus 1, the last element, or actually distances of n, sorry, and we should be happy. Oh, I wrote I somewhere instead of current. Whatever, let's just change this to I. I think I just kind of, you know, I mean, to be consistent with the notations. Out of bounds, if it's I. Oh, I wrote J minus. No, J is right. If I is. I see. I see. It's because when I is n, then it does crazy things. But maybe we can just, you know, if j is equal to n, then we're done. And then we just return this instance of I plus 1, because this is just BFS stuff, right? Why am I return? Is it from here? Apparently, it's a very basic thing, but I am running into technical difficulties. Okay, so j is equal to n. Right? Huh. Am I not? Oh, I'm forgetting the -1 case, obviously. So if I'm just being dumb. So if this is greater than or equal to infinity, then we turn -1, because that means that we're not able to get there. Yeah. I totally blanked out on it. What? I'm not gonna lie. I 100% thought that was done. But what did I click on? No, not editorial. I wanted to click on. Oh, I did click on editorial, but I meant to click on use test case. I mean, I didn't really see it, so I don't. 9 and 10. What am I doing wrong? Am I missing something, or off by 1, or just not understanding this correctly? Huh. I don't know, to be honest. And this is like a impossible. I mean, I don't know. It's probably not impossible, but just like a ridiculous thing to debug. Alright, so this should be 1, right? Okay, but this one, yeah. So that means that we should be able, for this test case, just remove this and have a slightly easier debugging. And it still should be incorrect. Okay, that's good. That's what we expect. Honestly, I mean, am I missing something? I mean, this is BFS. I don't think there's any way to really miss this. Oh, I am dumb, I'm dumb. Because this lets me go backwards. How did I mess that up? Okay. This lets me go backwards, so I was doing like back. Okay. I was just lazy on typing. And let me think whether it's I or I plus 1. I think this is I plus 1 actually, but maybe I'm wrong. Yeah, let's give it a submit. Hopefully not too long this time. Okay. Alright, that was just a silly mistake. I think I'm not gonna lie, I have gotten worse since doing these YouTube videos, because sometimes when I explain things and I'm talking about it and I'm, you know, writing these comments, and maybe this is an excuse to you at home, but when I'm writing it down, I slow myself so much to try to explain it that by the time I actually write the code, I forget bits that I'm trying to remember, and I'm so used to, and I don't know if this is a humble brag, but I am so used to being like faster that like it doesn't have to stay in my memory for long, because I'm already, you know, I already finished typing. So then, like, I have to, I don't know, it's a whole spiel. But this is kind of dumb. And if you really want a deeper, like, visual explanation, it's just that here, I accidentally have edges that are, like, you know, like going here. Oops. No. Like going here. And maybe there's a case in which if you go back and go forward, it's faster in the shortest path kind of way. And I accidentally did that. But yeah, when I saw that, I was like, huh, that doesn't make sense. But silly mistake. But anyway, this is BFS. This is going to be O of V plus Y, where V is the number of nodes, and which is O of N, and Y is the number of edges, which is V squared, which is why this is N squared, which is why, you know, given that N is 1000, we are Gucci. There are probably ways to make this a little bit faster. You could probably, I mean, I think there is a version of this which it's a heart, and maybe this is like 100,000 or something, or a million, I don't know. But it based, and you have to do like a Civ thing to kind of do the groups of them all at the same time or something like that. And maybe I'm wrong, but that's all I have for this one. Let me know what you think. Thanks for watching, and yeah, stay good, stay healthy, do good mental health. Silly mistake. I'll see y'all later and take care. Bye bye.